Hey everybody, just wanted to take a minute this morning and just share with you a thought that came to me. And a lot of my podcasts, a lot of my videos that I make, we'll talk about different types of telescopes that are used. I'll actually show over on Patreon some of the telescopes that I own and that I use on a regular basis. But I think in terms of articles and news that comes up, there's a whole variety of telescopes that are talked about. And I thought it would be really good to talk about 4 of the major telescopes that are out there that you're going to hear probably on a regular basis. And then as you can see on my screen, there's a whole listing of different telescopes here. And you can actually, like this is coming out of Wikipedia, this image, but it shows you the size and the different types of mirrors that are being used. Most telescopes today are what's called reflectors. These are instruments that light comes down and is reflected and then captured. Most professional telescopes are using these mirrors, or a combination of mirrors that are put together. Here you can see this is the extremely large telescope planned for 2028. Hopefully it gets done on time, but it's just a series of many mirrors that are put together to form a huge, gigantic mirror that improves imaging. Okay, there's also X-ray and gamma ray telescopes. These specialize to capture high energy light blocked by Earth's atmosphere. You have Chandra, XRISM, and Swift are examples of these. And then, like I said, I'll share over on my Patreon at Easy Astronomy amateur telescopes that are used and the ones that I actually use. And so there's a whole variety out there. But I thought we'd start today and review the 4 major telescopes used by astronomers in the world today. These are the probably 4 most well known. We have the Hubble Space Telescope, the James Webb Space Telescope, the Euclid Space Telescope. All 3 of those are up in space outside of Earth's atmosphere. And then we have the new Vera Rubin Observatory, which is in Chile, and that's ground-based here on Earth. The main features that distinguish these telescopes are mirror size. That determines their light gathering power. The larger the mirrors gather, more light, enabling telescopes to actually see farther back. And as that light's coming to us, they're actually looking back in time at it. So that allows them to see more distant objects in space. Also the field of view. Some telescopes see a very tiny patch of the sky, but with great detail. You can think of Hubble, you can think of James Webb. They're really good at that. Others are very wide field, like the Vera Rubin telescope, and they don't let us see a lot of detail, but they allow us to see many objects and farther back sometimes. Exposure time. Most of these are used with cameras, and the camera collects the light, and so the sensitivity of the detector or the camera matter. And because of these trade-offs, every telescope is designed for a specific type of mission or research goal in mind. We have space telescopes, like I said, like the Hubble, the James Webb, the Euclid. They operate well above Earth's atmosphere, so they don't suffer from what we call atmospheric interference. There's no twinkling stars, no absorption of the light wave. The best way to explain this is if you've ever had goggles on and you've been in a swimming pool and you go down near the bottom of the pool and look up, you get, from just the motion of the water above you, a lot of distortion going on. It's the same thing with Earth's atmosphere. When we're looking up through the atmosphere, there's a lot of distortion that can go on above us that can impact our images. We've actually got pretty good about using technology to kind of dampen out those influences on some of the major telescopes in our day. There's ground-based telescopes like the Vera Rubin Observatory. They can be built with much larger mirrors and huge complex cameras, because you don't need to launch them into space. That's when you put something up in space, you have to get it there. That limits the size of what you can do compared to the technology of getting it there. Also, ground-based telescopes, their cameras, their instruments can be big and sophisticated, often unmatched in size and complexity compared to the ones up in space. The downside, like I said, they look up through Earth's atmosphere. The atmosphere can distort light. Stars can twinkle. They can block some wavelengths, like ultraviolet, Many X-rays entirely are blocked by that. So some ground-based telescopes use tricks like what I'm talking about, like adaptive optics, to correct for that atmospheric turbulence that's going on, and that helps them to produce the sharper images. But still, space telescopes are probably always going to win in clarity for now. What each of these four telescopes excel at, Hubble and James Webb, they're designed to look very deep at detail at specific objects in distant galaxies, nebula, structures inside galaxies. Their field of view is not wide, it's very small, but the resolution and the sensitivity are excellent. That's why we get such great images from there. The Euclid, which is in space, and the Rubin on the ground are designed for sky surveys. Okay, they're taking images of huge part of the sky, so they have a wide field of view, and they're covering many galaxies, many objects, and they do it quickly. This helps astronomers map large structures out there in space in the universe and track many objects over time, and they can actually catch transient events like supernova that are happening very briefly. You know, a supernova blows up, it expands, it brightens in light, and then that light fades as the supernova fades. For example, Rubin will scan the same sky regions repeatedly, which is valuable for studying how objects change over time. The point detailed microscope telescopes like Hubble, like James Webb, complement wide angle or survey telescopes like Rubin and Euclid. Astronomers can use both depending on what it is they want to learn. What is the purpose and the outcome of the research that they're doing? So space telescopes allow us to avoid the atmosphere problems and see faint cosmic distant objects with clarity. Ground-based telescopes are built as massive instruments, unlikely to be sent to space because of their size and complexity. Wide field survey telescopes catch many objects and events, especially over time, and narrow field, high detailed telescopes let us zoom in on specific things. Between them, telescopes give astronomers both the big picture, the structure, the distribution of galaxies, the evolution of the universe over time, and then the close-up details, the structure of galaxies, stars, nebulas, planets, and things like that. And because the universe is so vast, so big, and so varied, one type of telescope could never, ever accomplish all these things. That's why we have so many and a wide variety of telescopes out there. Again, the major space telescopes, James Webb, it's an infrared specialist. It's a successor to the Hubble, providing many stunning deep views, allowing for research on specific objects. We have the Hubble still up there. Its iconic optical UV observatory, still delivering crucial data to us, still being used. For example, with Comet 3I Atlas, Hubble took images of that. The Chandra X-ray observatories up in space, it details high-energy X-rays for black holes, galaxy clusters, supernova. You can see from one of my recent posts on Cassiopeia A, Chandra was actually used to discover that right before the star that caused the remnant for Cassiopeia A, it had a silicon and neon interaction that really caused turbulence that probably triggered that supernova prior to the explosion. Anyway, so Chandra can reveal things like that to us because it's in the X-ray. Leading ground-based telescopes are optical and infrared. We have the extremely large telescope. It's an upcoming giant in Chile. It's being built with a 39 meter mirror. It's the world's largest. You can see that here compared to all the other ones. You can see, this will show you the comparison. That's planned for 2028. Hopefully it gets done. We have the Keck telescopes, and I just saw those over here. They're two mirrors that are great for they're two twin 10 millimeter mirrors in Hawaii, and they're up on a mountain there at about 10,000 feet, and you can see them right here. Together they help to really compact, and you can see in the dotted line the size image that together that they produce. You have the Grand Telescope in the Canaries, the GTC. That's the largest single mirror, 10.4 in the Canary Islands. You also have the Giant Magellan Telescope, GMT, and the 30-meter telescope, TMT. They're under construction for the next generation of telescopes. And then, of course, you have the Vera C. Rubin Telescope Observatory, which is in Chile, up in the Atacama Desert. And here you can see the size of that mirror. And it's starting for major surveys of the southern sky, looking wide field again. We have radio and millimeter arrays, the Atacama Large Millimeter Sub-Millimeter Array, or what we call ALMA. It's a powerful array in Chile. It's really designed for cold universe studies. The Jansky Very Large Array, the VLA, it's a classic radio informator that we use. And then the Square Kilometer Array, SKA, it's a future massive global radio telescope project. And then, like I talked, there's different types of telescopes to use. And actually, what I'm going to do is, let's pop over here. I'm going to post this over on my Patreon. Here's the comparison of the 4 major telescopes that I basically talked about. And you can see here, primary mirror, aperture light gathering ability, field of view, survey style, what it's good for, its strengths, limitations, what it's not ideal for. And then below that, I have an extended comparison of telescopes, classic, big, and upcoming. Here you can see we have the Nancy Grace Roman Space Telescope, Habitable Worlds Observatory, HWO, proposed for the future. Here's the KEX that I mentioned, the Giant Magellan or GMT telescope, which is under construction, the 30-meter telescope, TMT, which is planned, the very large telescope, VLT. I actually mentioned that in a post, and so anyway, I'll put this over on my Patreon page at Easy Astronomy. The goal is just here to get you familiar with some of the telescopes that are out there, so that when you hear them, you kind of get an idea of what they're being used for. And when they say a research paper, or we discuss a research paper, or another site that talks about a paper, you'll kind of get a feeling for which telescope is used, perhaps understand why they use that telescope, and help you to just gain further understanding of what's being used by modern astronomers today. Okay, hope you have clear skies, and hope everything's going great for you. Talk to you later.